Okay, Stats Kids, we're on the second half of section 3.3. This is the last section of the chapter. This chapter's gone really fast. And I'm going to start off with example 4. I thought I was going to be back today, but I have to take a kid to a different appointment tomorrow, or today, I guess you're watching this today. And so I will not be back until Monday. But we're starting with example 4. I'm going to, oh gosh, now my pager's going to go off. It's just a test page. Nobody's hurt. I'll go into a different room. Example 3, though, we were finding a percentile using a data value. So we said 11.8, what percentile is that? And so we went with how many people were below you, which was 20, right here, out of the total, which is 50, and that's 40%. Take it times 100, which is the 40th percentile. Now, I said don't write it with a percent. Write it as either the 40th percentile or you can write it as P40, okay? That is a pretty easy method, right? Pretty easy way. But when we have things where we're converting to like from P25 to the actual number, this is where it gets a little bit more difficult, okay? So watch this process, and there's a little bit of a different process when you're doing ones where it comes out even versus it comes out as a decimal. So I'll show you how that works, okay? So here we go. Ready? If we're doing the 25th percentile, the 25th percentile is 0.25. Right? Like if I would make him a percent, he would be 0.25. Now what I'm going to do is I'm going to multiply by, I think they have this over here, right here. Yeah. The percentile. So that you take K and you divide by 100. So 25 divided by 100 is 0.25. I just already started there. Sorry, I'm skipping steps, okay? So 0.25 times N. And N is the number of numbers that I have. So up here I had 50 numbers. I'm going to multiply that by 50. Now I got to go get my calculator. It's in the other room. Hold on. 0.25 times 50 is like 12.5, I think, or something like that. Let me check. Yeah, it has to be 12.5. That was silly. 0.25 times 50 is 12.5. Okay, equals 12.5. All right, now, that's that, right? 12.5. If you get a whole number, if that 12.5 would have been a whole number, you are going to average, well, I'll get to that. Since it's a decimal, okay, we're going to follow along this progression. It's not a whole number, it's a decimal. So we are going to always round up to the next largest number, right? So even if it was 12.1, we would go up to 13, okay? And what I'm going to do is 13 is not my answer. It's the 13th number, right? Okay, so I'm going to go up here and I'm going to say this is 10 right here, 10 across the top, 11, 12. The 13th number is 7.9. 7.9 is the number that is in the 25th percentile. Okay, so let me backtrack that again. We take 0.25, the 25th percentile is 0.25 times 50 numbers, that's 12.5, but I can't find the 12.5th number, right? So I do the 13th number because I always round up, and then the 13 number ends up being 7.9, okay? Good. Now we're going to do P40 down here, okay? P40 again, 40 divided by 100 is 0.4, so 40% is a decimal is 0.4. I'm going to take that times 50 numbers again because there's 50 numbers in my data set, okay? 0.4 times 50 ends up being 20, right? So that one did come out nicely. But here's the kicker. You can't just take the 20th number. The 20th number would have been 11.6, all right? And here's why, okay? If you take the 20th number and you then like do this method up here where I'm talking about converting it to the percentile, right? 11.6 has how many numbers below it? It has only 19 numbers below it, right? And 19 out of 50 would not end up being the 40th percentile. It would be like the 38th percentile. So what I have to do is if it comes out to be a whole number, you average the 20th and the 21st number together, okay? So the 20th number, let me erase some junk in my data set, okay? The 20th number was 11.6, the 21st number was 11.8. So I'm going to average 11.6 and 11.8. If I add those together and divide by 2 or just find the middle of them, it would be 11.7. Now note that 11.7 is not even an actual data value in my set, but 11.7 would live here, and then how many people would be below 11.7? 20. which would be the 40th percentile, okay? So if it's a decimal, you round up and take that number. If it's a whole number, you average that one, the 20th number, like this one, and the next number together. And that's what it says here. The value, if it's a whole number, this is your chart. If it's a whole number, you add the elf value to the next value and divide by 2. So that would be like the 20th number and the 21st number and divide by 2. You find the average of them, okay? So that might be a little bit difficult until you do it a couple times. Come back to example 4 and example 5 to know what to do, because you're going to have to look over that, okay? That is going to be exactly like what you're going to do on number 21 through 28, okay? So if you get stuck, come back to this example 4 and 5 to know, what do I do if I get a decimal? What do I do if I get a whole number, all right? Decimal is actually the easier one, right? You just go up to the next whole number, right? This one is where you have to average if you have a whole number, okay? All right, now we're going to talk about box and whisker plots. Okay, example 6 is box and whisker plots, okay? And the thing that you need to make a box and whisker plot is you need what's called the 5-number summary, okay? On your homework and on your test and everything, I'm going to ask you for the 5-number summary, and here's what it is, okay? Oh, I got to have my table stuff. Okay, I have my min, and I have my max, and I have my median. Those are 3 of the numbers of your 5-number summary, okay? Then I have Q1, which is the first quartile, and then I have Q3, which is the third quartile. The second quartile is the same thing as the median, so I just call him the median. Those are the 5 numbers that I need, okay? And they want us to use, oh, this is where I wish I could go back and forth, all right? This is where I wish I had this table down below, but whatever, okay? They want the minimum value, and these are in order. So the minimum value is 0.8. The maximum value is 77.8. Okay, so I'm going to write that down here. 0.8 is the min, 77.8 is the max, okay? So there's that, all right? Now I need to find the median, and the median is the middle number, and I have 50 numbers, okay? So I'm not going to do the cross thing, okay? If I have 50 numbers, I will not have an exact middle number. There will be 25 numbers on this half and 25 numbers on this half, okay? So what I'm going to do is I'm going to average the 25th number and the 26th number, and that's going to give me my median, excuse me. I'm gonna average the two, and that's gonna give me my median, my middle number. So the 25th number, this is 20 right here, 21, 22, 23, 24, 25. 25th number is here, 26 numbers there. So I'm gonna average those two middle numbers together, okay? 13.7 and 14.1. 13.7 plus 14.1 divided by 2. Maybe you can do that in your head, but it's been a long day. 13.7 plus 14.2 divided by 2. I get 13.95 is my median. Okay, that's my middle number. Now, here's the deal. Here's the trick with finding the median and the quartile 1 and quartile 3, okay? So I'm going to do just a little sub-example over here. Let's say I have the numbers 1, 2, 3, 4, and 5, right? My min would be this number. My max would be this number. My median is 3. Okay, now, if I have an exact middle number, I'm going to cross off that middle number, and I'm going to find Q1 is going to be the median of what's left over here, okay? So Q1 would be the average of 1 and 2, so it would be 1.5. Q3 is going to be what's left over here. I'm going to find the average or the median of those guys, and that is going to be 4.5. Okay, now if it ends up being that I have, like, let's say 1, 2, 3, 4, 5, 6, right? My minimum is 1, my maximum is 6. My median, though, is 3.5, right? He's like the middle of those two numbers. I did not have an exact middle number, so when I go to find my Q1 and Q3, I get to include 3 and 4 in that calculation. So Q1 will be the middle of these numbers. Q3 will be the middle of these numbers, right? So 2 is my Q1 and 5 is my Q3, all right? So if you have a median, you cross it off and you use what's left to find Q1 and Q3, okay? If you don't have a middle number and you had to average them, then you get to use those guys to find Q1 and Q3, okay? So I'm going to go back up here. We did not have a middle number, right? So what I'm going to do is, after I erase, is my middle number was right here. Okay, I get to use the 13.7 and use the 0.8 to find my middle number. Okay, there was 25 numbers there. And if I'm trying to find the median of just those 25 numbers, there'll be 12 of them here, 12 of them here, that's 24. But then the one number in the middle of those two 12 sets will be my median, okay? And that will be like the 13th number, right? 12 numbers here, 12 numbers there. So I'm going to go to the 13th number. There's 10 numbers here, and then 11, 12, 13. 7.9 is my Q1, okay? Then I'm going to do the same thing, and I'm going to go 13 numbers, but I'm going to go from the back. 1, 2, 3, 21.5. That is my Q3. Okay, it's 13 numbers from the back, or 13 numbers this direction, right? So Q1 was 7.9, Q3 was 21.5. 7.9, 21.5. Okay, that's my Q1 and Q3. It's like the median or the middle of your first half of your data and the middle of your second half of your data. Now, what's really fancy is that Q1 also could be called P25. It's the 25th percentile, right? Okay. In fact, we did that, right? P25 ended up being 7.9. It's the 25th percentile, right? That's what Q1 is. Q3 is another name for the 75th percentile. The median is another name for the 50th percentile, right? It's like that middle number. Okay, so that's how that works. I just go and count and do the median and all the things normally, but you could check that with the P25 stuff, and you should get the same number. Okay, so that's how that works. Now they want us to construct a box and whisker plot with this, okay? And what I do first, because it drives me nuts when kids don't do this, my minimum number is 0.8, my maximum number is 77.8. So what I'm going to do is on the bottom here, I'm going to draw a straight line. There we go. You straightened out for me. And my smallest number is 0, like close to 0. My largest number is close to 80. So I'm going to do that. And then I'm going to do, that's really not a straight line, but I mean straight, but it's not like, it's angled. Whatever. 40, 20, 60, and then 10, 30, 50, 70. Okay. So there is that. All right. Now I'm going to make a box and whisker plot. I hope you guys have done this before, I hope. 0.8 is going to be a dot. I'm going to put a dot right above the 0 because that's 0.8. 77.8 is over about there. Those are my dots. And those are the dots for like my whiskers. And then here is where my box is going to be. Okay, so we're going 7.9, which is maybe about there. That's the edge of my box. 13.9 is going to be about there. And then 21.5 is about there. Here's my box. Woo. Making dotted lines here. And there's my whiskers. Now, it says a box and whisker plot can be used to identify skewness, okay? So one thing that I have my Algebra 2 kids, I think, whenever we do this in Algebra 2, is we talk about like how many numbers live here versus how many numbers live here. And they always say there's more numbers living here than there are here. No, there's not. There's the same number of numbers in this region as there are in this region, right? It's just that the numbers in this region are more spread apart and the numbers in this region are closer together, right? So in each one of these 4 sections, there's the same number of numbers, right? Just the fourth quartile is going to end up being more spread apart. Like there's 8 minutes in each. Is there 8 minutes in each quarter in basketball? 8 minutes? I don't know. 8 minutes, 8 minutes, 8 minutes. But a lot of times it feels like that fourth quarter is longer because it gets drug out and then we're stopping the clock all the time and whatever. Okay? Because people are fouling out and whatever, right? So that's kind of how that works, all right? This guy would be right skewed. Okay? Because the box is on the left. So the majority of the data is on the left, so it would be right skewed. It's kind of like that toe thing, you know, where like your right foot looks like this, right? That's my right foot, okay? So it is right skewed, okay? So that is my box plot, okay? I think I'm going to stop there, and we'll talk about outliers, part 2, and then we'll compare box plots on Monday. So you should be able to do that, but you should be able to do all the homework now, I think. If you did not get done with homework, finish it. But you can add to that 21 through 31, I guess. And here is your line to use for your box and whisker plot, but put your box and whisker plot up here. This is like your ruler to mark, okay? All right, there is that. Yeah. Have a good weekend.